Hey guys, welcome to our third online lesson for College Trig. Um, I know we all just kind of got the news that we're not coming back to regular school this school year. So not sure how you guys feel about that. I know I have certain feelings about it. No, it sucks for all you seniors, prom, graduation. Not sure what's going on yet. Um, but would love to chat with you guys if you want some online, math help or just want to chat, come in for the office hours, message me, whatnot, do miss you guys. So, starting from here on out with the lessons, it's going to be new stuff, so I'm assuming we'll need some more help. So I'll still be doing the office hours Monday through Thursday with some sign-ups on Friday, so you can get some help if you need it. Um, Apologize if there's any mistakes on this slideshow. I'm doing it at like 2 a.m. because, doesn't seem like time much matters during this lockdown. So let me get my pen working here real quick. Sometimes it takes a few tries and still not working. Let's try green. Nope, hold on. It's gonna work. And let's try blue. All right, blue works this time. So today's lesson is on half angle formulas. These are the last formulas we're going to use, the last identities, before we go on to some more computational type problems. Usually this unit would last another couple of weeks, but these are different times, so we're not doing all the identities that we had planned. So half angle formulas. First of all, here they are. Um, we've got a tangent, we've got a sine, we've got a cosine, just like before. Um, and they're all half angles, so something divided by 2. Um, Down here it just says the signs of the half angles depend on the quadrant at which u is in anyways, the angle u. So we notice that each of them actually has 2 versions. Sine has a plus or a minus, cosine has a plus or a minus, tangent has 2 completely separate versions. So it really just depends on what situation we're in, where stuff is. Um, so I'm just moving this so you can see. Depends on where the quadrant in which u over 2 lies. So you got to worry about your chart. Oops. Let me try this again. So remember we have plus for all 3. Over here, sine is positive, cosine and tangent are negative. Down here, we have negative sine, cosine, and positive tangent. Over here, we have negative cosine, positive, or sorry, negative sine, positive cosine, negative tangent. So you'll have to worry about that with u over 2, but only for the sine cosine. So this is very similar to some difference in and double angle in that for the most part it's to get exact values of angles that are not on the unit circle. So uh, between the 3 of these sets of formulas you should be able to find any exact value you need for any angle from the unit circle. So let's give it a try. So our example number 1. Find the exact value of sine of 105 using 2 methods. We're going to use half angle and we're going to use sum difference. So hopefully remember, those off the top of your head. So we have sine 105 and we're going to solve that 2 ways. Let's do the sum difference since we know that. I'm going to rewrite that as sine 60 plus 45. So sine 60 plus 45 is sine 60 cosine 45 plus cosine 60 sine 45. Sine 60 is square root of 3 over 2, cosine 45, square root of 2 over 2, cosine 160 1/2, sine 45 square root of 2 over 2, so that turns into square root of 6 over 4 plus square root of 2 over 4. So all over the same fraction. Kind of sped through that because, well, that's a couple lessons ago. So that one should be more familiar. Now, the one that's less familiar is the half angle. So let me do it on the next slide. So we can say sine 105 is the same thing as sine 210 over 2. So the idea here is that 105 is not on the unit circle, but 210 is. So we want to be able to use that for us. So going back to our half angle formulas. So we got this right here. Sine 105, first of all, is over here-ish, which means sine will be positive. So I've got positive, oops, wrong button, and then square root 1 minus cosine u over 2. So square root 1 minus cosine, in this case u is 210, over 2. All right, I paused the video for a second there so I could pull up a unit circle to be able to work with. Because right now we have to figure out, let me get my pen working, what cosine 210 is. So flip into a unit circle. Where'd it go? There it is. All right, so cosine 210, if we look here, is going to be negative square root of 3 over 2. So negative square root of 3 over 2 is what I'm going to replace that with. And technically, that's a good enough answer. You could do some simplifying if we want. Let's see. I could write 2 over 2 over 2, which is going to, let's see, if I write over 1, copy dot flop, I get 2 over 2 minus square root of 2 over 2 times 1/2, which means the bottom is going to turn into a 4. So 2 minus square root of 2 over 4. I mean, we could do that. That's just a more simplified version. But really, this one's good enough as it is. Now, if we look back at the problem real quick, it says, and show that they are equivalent. So what I've shown you before is that we can use our graphing calculator, which is what I'm doing right now. Let's see, square root of 6 plus square root of 2 divided by 4, that gives me about 0.9659. Okay. So over here is the exact value. This is the approximated value because it's been rounded. All right, let's try either of these. Doesn't much matter. They should give me the same thing. So I'm going to do square root of 2 minus square root of 2 divided by 4. And you should get the same thing. Okay. So you should be able to check and see that you got it right. Depending on your simplifying, it may or may not look like the same exact thing. Just checking one more thing on my calculator real quick. I feel like I goofed on something in my simplifying. Cosine 210 is negative square root of 3 over 2 Let me go back. 1 minus cosine 210. Yeah, I'm stuck all of a sudden. Hold on, let me double check something. Um, Cosine 60 plus 45. Okay. Um, Sorry, I just messed up how I typed in the calculator for a second. We're all good. So, going back to this problem, 1 minus cosine, the double angle, essentially, divided by 2, and then you go. Let's try another one. So in this case, we're given a triangle to figure out from there. So find the exact value of this, and we're given a triangle. So sine of theta over 2, given that. So we already know that theta over 2 is plus minus. In this case, we're not given a quadrant. Technically, we can choose first, or we can assume first quadrant since these are all positive. Um, so let's just assume first quadrant, but we can leave this plus minus if we need to. And 1 minus cosine theta over 2. So all we got to do really is fill in the blank of cosine theta. So plus minus 1 minus 1517 over 2. And technically that's a good enough answer. Technically it should probably be a positive since all these are positive, so we can assume first quadrant since it didn't tell us otherwise. But if it tells you the quadrants, be careful so that you know that you're using the right positive negatives. You could do a little bit of simplifying from there. Okay, not going to hurt you. So otherwise, that's really all you got to do there. That's the exact value. Let's try one more. 2 cosine theta over 2, tangent theta over 2. So this one just uses a couple half angle formulas with the same exact triangle. So I'm going to flip back. Cosine theta over 2 is right here. Once again, we don't really know plus minus, so I'm not going to worry about it at the moment. 1 plus cosine u over 2. And then times tangent. Oops, tangent doesn't have a square root. So times tangent, which I could really use either of these that I want. I already used cosine u, so I don't know. I can use 1 minus cosine u. Looks similar. 1 minus cosine u over sine u. So times 1 minus cosine theta over sine theta. At this point, I can rewrite it. I'm just going to move up here. 2 square root 1 plus 1517 over 2 times 1 minus 1517 over 8/17. So 1517 comes from the cosines, 8/17 comes from the sine. So that's our exact value. It looks pretty messy. You could do a little bit of simplifying, really not a whole lot, but you know, it's good enough at the moment. And so all you gotta do is plug in the right numbers, the right formula, and you're good. Doesn't matter which tangent you use. Just be careful on your plus minuses if you're told which quadrant. So that's it for our half angle formulas. So please check out office hours, email me, contact me if you need any help. Just let me know what you need. Give me some feedback as far as are the videos helping? Are they not? Do you need more of something? Just let me know. Otherwise, I'll just keep doing this and hopefully it's helpful for some people. So hopefully see you on the other side of this, seniors. guess I might not see some of you again. But hopefully, we communicate and you check in during this time with these online lessons so that we, at least, we have that. So see you on the other side. I'll put together a fourth lesson at some point this week, probably for Thursday. Bye.